Hello, Math 109 students. We're on Chapter 5. This is the second video. Part 1 covered questions 1 through 18, so we'll start with number 19 on this second video. Use the remainder theorem to find the remainder when f of x is divided by x minus 2. Then use the factor theorem to determine whether x minus 2 is a factor of f of x. Okay, so what I would do on this problem is I would use a method called synthetic division. All right, so synthetic division is a pretty neat little method to divide a polynomial by another polynomial. And what you can do is you make a kind of a box thing. I guess it's kind of like a half of a box right there. And what you put inside the box is you put these coefficients, the 3, the -3, the -9, and the 7. That's what's going inside the box. The polynomial that you're dividing into is the coefficients are going inside the box. 3, -3, -9, and 7. And notice I left a little bit of space between them. And what's going to go outside the box is the prospective solution or zero or root of this factor. All right, so we're dividing it by x minus 2. So we're trying to decide, is x minus 2, does it divide evenly into that polynomial? In other words, is x minus 2 a factor of that polynomial? And if x minus 2 is a factor, then that means we should be able to set it equal to 0 and get 2 as the zero, as the root. And so this is actually what we're going to put on the outside of the box. So you'll always put the opposite number from the factor outside the box. So inside the box we have the coefficients of the polynomial we're dividing into. Outside the box we have the opposite number of the polynomial that we're dividing by. Then you're going to follow this two-step process. Add down, multiply across, and then you're just going to repeat that all the way to the end. That's it. That's the process. What do I mean by that? What I mean by that is the add down means I take the very first number inside the box, the 3, and I add down 3 plus whatever's below it, and there's nothing below it. So 3 plus nothing is 3, and I write that result down below the box at the bottom. That's always going to happen on the first number. There's never going to be a number below it, so it's just always going to come down as it is. Then when I say multiply across, what I mean by that is I take the 2 on the left side of the box, I multiply it by the 3 that I just wrote down below the box, and I write it underneath the next number across. So 2 times 3 is 6, and I write that below the next number across. Then I just repeat the same process over again. I repeat the same process over again. I add down. So -3 plus 6 is 3. And then I multiply across. So I take the 2 on that left side of the box, multiply it by the 3 that I just wrote below the box, and I write the result below the next number. So 2 times 3 is 6, and I write that below the next number. Repeat the process again. Add down. -9 plus 6 is -3. Multiply across. 2 times -3 is -6, and I write that below the next number. Add down. 7 plus -6 is 1. And I'm done because I went all the way to the end. Okay, now what does that do for us? This last number is kind of what it's all about for this question, because this last number is called the remainder. the last number in this process is always the remainder. So when I divide this polynomial by this polynomial, I get a remainder of 1, which means it's not a factor. It doesn't divide evenly into it. If it was a factor, the remainder would have to be 0, right? When you divide numbers, like back in our good old long division days, if you divide 8 by 4, you're going to get 2 with no remainder. But if you divide 9 by 4, you're going to get 2 with a remainder of 1, because 4 is a factor of 8, but it's not a factor of 9. So if you get anything but 0 here, then it's not a factor. So let's go to this question and type in the answer. The remainder, in our case, was 1. And that means x minus 2, is it a factor? It is not. We're going to answer no to that. Okay, here's a similar problem for number 20. All right, again, we're using the remainder theorem, so I'm going to do synthetic division again. I'm going to draw my box, and there's another piece of news about this that I have to inform you of. I'm going to put these coefficients inside the box, but for this one, there are coefficients that are missing from this polynomial. Not really, but for synthetic division to work, it has to be arranged in a particular way. Okay, whatever the leading coefficient is, whatever this leading term is, this is 2x to the 6. I'm going to put a 2. Oops. I'm going to put a 2 as the first number. But then since the first term is the x to the 6th, the next number I write needs to be the coefficient of an x to the 5th term. So it's like 2x to the 6th plus 0x to the 5th. Because there is no x to the 5th term, so it'd be like having a 0x to the 5th. So I got to put a 0 next. That's called a placeholder. When it skips terms, when the polynomial is kind of skipping over terms, I have to put a 0 in as a placeholder for that term. Notice also there's no x to the 4th term. That's what needs to come next. So I'm going to put a 0 as a placeholder for that one too. Then there's the x to the 3rd comes next, which I do have that. That's a 4. All right, but then I don't have an x to the 2nd. So I'm going to put a 0 over that there. I'm not going to continue writing that. I'm just wanting to write that to give you an idea of why we're doing what we're doing. So I have a 0x to the 2nd. I also have a 0x to the 1st. And then I have a 2 at the end as a constant with no variable. So I had to have actually 4 placeholders in that polynomial to do synthetic division with it. All right, now what am I going to put outside the polynomial? I'm going to put the opposite of this. When I solve it, I will get x equals -1. I'm going to put -1 in for that. And I'm going to follow the process. Add down, multiply across. Add down, multiply across, all the way down. So once you get some practice at this, you can go really fast. All right, 2 plus nothing is 2. -1 times 2 is -2. 0 plus -2 is -2. -1 times -2 is 2. 0 plus 2 is 2. -1 times 2 is -2. 4 plus -2 is 2. My goodness at the 2's. -1 times 2 is -2. 0 plus -2 is -2. -1 times -2 is 2. 0 plus 2 is 2. -1 times 2 is -2. And 2 plus -2 is 0. Wow. Okay, so what is this? This is the remainder. The remainder is 0. Okay, the remainder is 0, which means what? It means that x plus 1 is a factor of that polynomial. All right, let me get over here to the problem, type in the answer. The remainder is 0. And it is a factor. Okay, this next problem uses a concept called the rational root theorem. All right, the rational root theorem says that for any polynomial, the possible rational roots, rational means it can be written as a fraction, you know, it's like not irrational, like pi or something. The possible rational roots of a polynomial are always going to be of the form, let's say you had f of x equals, let's say a x to the n plus b x to the n minus 1 plus c x to the n minus 2, all the way down to some constant. Let's call that constant, let's just call that z. So however many terms you have in here, okay, the polynomial walks its way down to some constant. In this case, our example here, the 5 would be the a, the 1 would be the z. Okay, the possible rational roots will always be within the set of the factors of z over or divided by the factors of a. And any of these could be positive or negative. All possible rational roots of any polynomial will always be within the set of the factors of z divided by the factors of a. In other words, the factors of the constant divided by the factors of the leading coefficient. Let me show you how that works for this particular problem. All right, I'm going to have to erase this to give myself room to maneuver here. Okay, so the possible rational roots of this polynomial will be the factors of 5. I'm sorry, the factors of 1 over the factors of 5. So what are the factors of 1? The factors of 1 are just 1 and 1. That's it. The factors of 5, what are they? They are 1 and 5. So I've got to put any of these over any of these, but I don't have to repeat them. So I'm going to put 1 over 1. So like 1 over 1 and 1 over 5. And you know, since this is also 1, I don't even have to worry about that because it's the same exact number. And both of these, so that basically turns into the possible rational roots are either 1 and 1/5. And they could both be positive or negative. So the answer to this would be choice D. Negative 1, 1, negative 1/5, positive 1/5. Let me go put that answer in. D. All right, use the rational root theorem to list the potential rational zeros, so it's the same kind of problem. Okay, once again, it's going to be the factors of 5 here over the factors of 25. Don't worry about the 25 being negative. That doesn't matter because they can all be positive or negative anyway. So what are the factors of 5? 1 and 5. What are the factors of 25? 1 and 25 and 5 and 5. Well, since that's the same as the other one, I don't have to worry about that one. I don't have to write it twice, but I've got to put the 1, over each one of those. So I've got 1 over 1, 1 over 25, and 1 over 5. And then I've got to put then I've got to put the 5 over each one of those. So 5 over 1, 5 over 25, and 5 over 5. So there they are, but I need to clean that up. I'm going to clean it up. Okay, 1 over 1 is just the same thing as 1. And then 1 over 25. And then 1 over 5. And then 5 over 1 is just the same thing as 5. What about 5 over 25? What about that one? Well, that reduces to what? It reduces to 1/5. So I don't have to worry about that one because it's already represented in the 1/5. It's just a repeat. And then what about the 5 over 5? What's that reduced to? It just reduces to 1. So that also is already represented in the 1. It's just a repeat. So I don't have to write that twice. So all the possible rational roots are those numbers, and they can all be plus or minus. So let's see if we can identify that answer. -1, 1, -5, 5, -25, 20. That's not, A is not it because 25 is not in there. Let's try this one. -1, 1, -5, 5, -1/5, +1/5, -1/25, +1/25. Choice D appears to be the right answer. Let me put that in there. And it's correct. All right. For the following, find the real zeros of f. Use the real zeros to factor f. All righty. I am going to show you a few different ways that you can do this. So, yeah. One way you can do this one, but won't work all the time, is by factor by grouping. I can tell this one will work by factor by grouping because 2 times 2 is 4, and 10 times 2 is 20. So I can tell it's going to work by factor by grouping that way. So if I factor by grouping, I will factor out the GCF from each group. The GCF here is going to be a 2x squared, and that leaves me with x minus 2. And the GCF for the second group is going to be -10, and that also leaves me with x minus 2. Then the new GCF is the x minus 2. So x minus 2 comes out and leaves me with 2x squared minus 10. Then I can solve both of those. I say x minus 2 equals 0, and I get x equals 2 from that. I say 2x squared minus 10 equals 0. And I got to do a few little steps here. 2x squared equals 10, divide by 2. X squared equals 5, square root both sides. X equals plus or minus root 5. So those are my answers. That's one way to do it. 2 and positive and negative root 5. Let me show you another way to do it. You can also do it by the rational root theorem and synthetic division. So we can say 2, -4, -10, and 20 inside the box. And what do we put outside the box? We don't know actually what to put outside the box, but we know it's going to be of the form of the factors of 20, 1 and 20, 2 and 10, 4 and 5, over the factors of 2, 1 and 2. So this is going to be a little bit painful at first, but I'm going to hopefully make this easier after going through the thorough process. So 1 over 1, 1 over 2, 20 over 1, 20 over 2, 2 over 1, 2 over 2, 10 over 1, 10 over 2, 4 over 1, 4 over 2, 5 over 1, 5 over 2. Let's clean that up. Okay, 1, 1/2, 20, 10, 2, 1 again, but that's a repeat. 10, again, that's a repeat. 10 over 2 is 5. 4, 2, 4 over 2 is 2, that's a repeat. 5 over 1 is 5, that's a repeat. And 5 over 2. So there's my possibilities. So what we used to have to do back in the day is we would have to try these things until we found one that worked. So like, I'd probably try 1 first, since that's kind of the easiest one to do. I'd try 1. If it worked, good. If it didn't, then I'd try -1. Then that might work or it might not. If it didn't, then I would probably try the next easiest one, which would be 2. And then -2. And if neither one of those work, then I'd have to try probably 4 and -4. Usually you're going to find one that works within the first 3 or 4 tries. But there is an easier way for you because you have a calculator. If you go to your calculator, wait for it to pull up here. Come on. You can just type in this. One way to do it is type in this function in your graphing application, 2x cubed minus 4x squared minus 10x plus 20 minus 10x plus 20, and then graph it. I'm zoomed strangely. I'm gonna hit zoom 6 to get back to my standard zoom window, and I can see kind of where these zeros are, although they're not very friendly. Let me hit second. Did I go zoom 6? Just make sure I am zoomed correctly. Zoom standard. Yeah, so second calc. I feel like that's just strange. Let me look again. Make sure I typed it in correctly. 2x cubed minus 4x squared minus 10x plus 20. Yep. Second calc. Calculate the 0. And let's see here. We can have a left bound be there and a right bound be there. And I get negative 2.236068. Yeah, that's not a rational root. That appears to be an irrational root. Let's try the others. Let me show you how, if I do the next one, I think it's going to work better. So if I'm finding this one here, I can let this be my 0. My left bound. And this one, since I know it to cross the x-axis because this is a negative y value, that can be my right bound. Hit enter again. And one of the zeros is 2. So 2 would work very well outside the box. That is one of my possibilities. I'm going to put 2 outside that box. And that's how I know which one will work. That's one way I can know which one will work. Let me see. There's also another way. If you go to apps, here's the apps button. Go to apps and go to polysimult 2. Polynomial simultaneous 2 is what it's short for. It's PLYSMLT2. Hopefully you have that app on your calculator. The newer ones probably will. The older ones, there's a chance they might not. You can download it if you've got a connector for your calculator. You can download that app from TI, the TI website, or even from another classmate's calculator. That if you got a connector that connects 2 calculators together. But the app is pretty cool. This will do 2 different great things. I think I've showed you already a couple things that this will do for you. It'll solve simultaneous equations, so like a system of equations. It will also be a polynomial root finder, meaning it'll solve a polynomial. So I'm going to choose option 1 because that's what I'm doing here. I'm trying to find the roots of a polynomial. The order is the highest degree in the polynomial, the highest exponent. So the degree of the polynomial. In this case, the order is 3. The degree is 3 for this one. The next line, you can have it only give you the real solutions, or you can have it give you both real and imaginary by selecting A plus BI. Usually I like to have the real and the imaginary solutions be given to me. The next line, you can have it give you a decimal or just automatically choose for itself whether to give you a decimal or a fraction for the answer. The next one, you can have it give you the answer as a normal number, a scientific notation number, or whatever ENG stands for. I'm not real sure. English notation of some sort. The next line, you can tell it to make your answer be a float, meaning it'll just do as many decimal places as it can fit on the screen, or you can fix the decimal point to 2 or 3 or whatever places. You might want to just fix that at 2 or 3 to make it simpler to read the answer. Otherwise, it can get a little confusing to read the answer. So I might recommend that to you. I'm going to keep mine at float, but I might recommend to you to do 2 or 3 decimal places here. Radian or degree does not matter. That would only matter in trig. Then you can't click down anymore. You can't get down here to these buttons. To actually get these buttons, you have to click the button below them. So like if this is my screen, the button below main would be y equals, the button below help would be trace, and the button below next would be graph. So if I want to go to the next menu, I hit graph to say next. Then I'm going to put in the coefficients of my polynomial. So for my polynomial, it was 2, enter, and then minus 4. So I could just leave that as a plus and then put -4 in the next thing, or I could have hit minus and then put 4, same thing. What was next? Minus 10x plus 20, so I'm going to leave that as a plus, or I could put minus. I'm going to put a -10 since I left it as a plus. And then plus 20, so just 20. Enter. And then to click solve, again, I have to hit the button below solve, which is the graph button. So I'm going to hit that button, and it's going to tell me my answers. And my answers are -2 point blah, 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 +2 point blah, 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 and 2. So again, this is another way. This actually gives me all my answers, but it gives them a couple of the irrational ones as decimals that would have to be rounded off. So if you were required to put an exact answer, you wouldn't be able to do it that way. So here's how we can do it. You just use the rational one, which was 2. So there are the other ways you can do it, either by graphing it and finding a rational x-intercept on the graph, or by doing the app and using one of the rational x values given to you by the app. Either way, 2 is the one that we would get. And then use synthetic division. Add down, 2 plus nothing is 2. Multiply across, 2 times 2 is 4. Add down, -4 plus 4 is 0. Multiply across, 2 times 0 is 0. Add down, -10 times 0 is -10. I mean, -10 plus 0 is -10. Multiply across, 2 times -10 is -20. Add down, 20 plus -20 is 0. And we should always get 0 as the remainder, because it has to be, because we already knew before we even started that 2 was one of the solutions here. So what do we have left? Okay, here's how we do it from here. What you have now is the rest of the polynomial, the polynomial that is left after you factor out an x minus 2. So what polynomial is left here? How do we know? This is the remainder. Okay, this is the constant. This is the x. This is the x squared. And if there were more, it would go on up to x cubed, x to the 4th, or whatever. Or another way you could think about it is whatever 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 degree I start with up here, a 2x to the third, after I divide with synthetic division, what's left is going to always start 1 degree less than the one I started with. So since this was an x to the third, what's left is going to start out as an x to the second. So what's left here is 2x to the second plus 0x, I'm going to leave that off, minus 10. That's what's left. So that, once I get it down to a quadratic, I can always solve it. You know so many ways to solve a quadratic. There is not a quadratic in this world that you can't solve. Using factoring or using the quadratic formula or using the square root method. I think here I'm going to use the square root method. I'm going to set it equal to 0, and I'm going to get x by itself by using the square root method, which is kind of what I had to do also when I factored it the very first way I did it. Square root both sides, x equals plus or minus root 5. So there is the irrational, the 2.236 and negative 2.236, blah, 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 answers, the square root of 5. So don't forget also that 2 was one of my answers that I already found. So 2 and square root of 5 and negative square root of 5 are 3 answers to this polynomial. And one more tidbit. You should always get the same number of zeros as the degree of the polynomial. The degree of the polynomial tells you how many zeros you are going to get. All the zeros may not be real. Some of them may be imaginary, but the real and imaginary zeros put together will always add up to, the number of them will add up to the same thing as the degree of the polynomial. So let me finally put in my answer. Notice this says simplify your answer. Type an exact answer using radicals as needed, which means I could not put in the rounded off decimal given to me by the app or by the graph. I had to do either factoring or synthetic division to get the exact answers. So let me go type those answers in. It was 2, comma, and I believe I can put, you can type in square root of 5, comma, negative square root of 5, or I think you can also just put a plus or minus and then square root of 5. So here's your square root symbol. You can click that. What I like to do is I like to do my little slash and then the SQRT. That puts a root symbol. And then 5 inside of there. That does the same thing. So I hope this is going to give me the right answer. And it does. Alrighty. Oh, I haven't finished yet. Use the real zeros to factor f. So what I have to do to that then is to use those zeros to factor, I just have to turn each one of them into a factor. So 2, I'm going to turn that into a factor by saying x minus 2. Square root of 5, I'm going to say x minus square root of 5. Negative square root of 5, I'm going to do that by saying x plus the square root of 5. So there's my factoring. Let me go over here and type that in. X minus 2, x minus square root 5, and x plus square root 5. Okay, so it told me I was wrong, and I'm remembering why I am a little bit wrong, just a little bit. This is kind of aggravating, but you're going to have to remember to do this. You remember how I have told you in the past, if you can take out a GCF, take out the GCF first. Always look for a GCF first. We should have done that. This 2x squared minus 10, or you can even go up to here, the whole polynomial, there is a GCF there and it is 2. We can factor out a 2. It would have left us with this, which would have been smaller numbers to deal with anyway. Or if I'd have done it here, I could have factored out a 2. So the point of that is that 2 itself is also a factor. So I'm going to, in my factorization, in my answer, I'm going to have to put a 2 in front of that whole thing for it to be right. So now all of this FOILed and distributed together will now result in this f of x polynomial that I started with. Click check answer, hold cross your fingers, and be ever so happy when the green check mark pops up. All right, same kind of situation. I think I will wait and save this one for a third video because this video is getting a little long. It's over 30 minutes now. So I'm going to stop this one here and come back to this one in the next video. So we got through number 23, 19 through 23 in this video. We will pick up on 24 in part 3.